Okay guys, welcome back. So in this video I'll be explaining you about the equations of powers, right? So you know about powers, right? Powers and indices. So in this video I'll be explaining you about how powers are used when solving a particular equation, right? Particular equation. So I'll take an example like this. So if you are given some example like this, say 3 to the power 2x plus 1, right? 3 to the power 2x plus 1 minus 28 to the power 3 to the power x plus 9 is equal to 0, right? Is equal to 0. So if you are given some equation like that, how we can solve? Now first of all you need to identify, in order to solve this equation, now you have the value of x. Now you have to solve for x, so you have the value of x in the form of powers. So if you were to solve for x, we have to take the logarithmic value and then solve for x. So how we can find the logarithmic value of such a term? So first of all you need to understand where you can put logarithms, how you can put logarithms, and how you can solve logarithms. So in order to do that, we have to arrange this equation in such a format in order to apply the concepts of logarithms. So you have 3 to the power x here, 3 to the power x here. So here you can write this one as 3 to the power 2x plus 1 here you have been given, and you can write 2x as 3 to the power 2 to the power x, right? Or something like that, right? And you can solve for that. So what I'll do first here is that I make this equation into the format of 3 to the power x. So we are given this one. I can write this one as 3 to the power 2x. I can write 3 to the power 2x plus 1 as 3 to the power 2x times 3 to the power 1, because you know that when you are multiplying with the same base, you add up the indices or the powers, right? Minus 28 times 3 to the power x plus 9 is equal to 0, right? So 3 to the power 2x is 3 to the power x squared. So this is equal to 3 times 3 to the power x squared minus 28 times 3 to the power x plus 9 is equal to 0. Now you have some term here, 3 to the power x. You have another 3 to the power x here. So what I'll do is I'll take a substitution. So I'll take this one to be t equals 3 to the power x, right? T equals 3 to the power x. So what I'll do is I'll substitute the value of t in place of here. So t is just a direct substitution, right? So this will solve for 3 times 3 to the power x is t, so that square is 3t squared. T squared minus 28 times 3 to the power x is t plus 9 is equal to 0. So 3t squared minus 28 9 plus 3t squared minus 28t plus 9 is equal to 0. So in order to solve for x, you need to find the values of t. So the values of t are the solutions of this quadratic equation. So I can solve this. So here is 27, here is 28. So the solutions will be 0. So 3t and 9, right? Here 9, and here t, you should have a t here, minus 1, right? Let's see whether it tallies. So 3t times t is 3t squared, 3t times minus 9 is minus 27t, that minus t is 28t, you get it here, minus 1 times minus 9 is equal to plus 9. So these are the solutions. So this factorized, this quadratic equation is factorized up to this format. So the solutions of this equation are the solutions when I equate these individual terms inside these brackets to 0. So those will be 3t 3t minus 1 is equal to 0 and t minus 9 is equal to 0. So that will be t equals 1/3 or t equals 9. Right? T equals 1/3 or t equals 9. So you know that t is equal to 3 to the power x. 3 to the power x. You can write 1/3 as 3 to the power minus 1. 3 to the power minus 1. Similarly, when t is equal to 9, t is equal to 3 to the power x. That is equal, you can write 9 as 3 to the power 2. So you can say x is equal to minus 1 or x is equal to 2. Right? X is equal to minus 1 or x is equal to 2. So those are the two solutions. Now just substitute and see whether this tallies. So that's a very good step you are taking towards finding the solution, because you will get solution but you don't know whether they are correct. So let's substitute these two values independently and see whether the right hand side is equal to 0. So when x is equal to minus 1, 2 times minus 1 is minus 2, minus 2 plus 1 is equal to minus 1. So 3 to the power minus 1 is equal to 1/3. Similarly here 3 to the power minus 1 is equal to 1/3, right, plus 9. So here will be 1/3 minus 28 times 1/3 is 28 by 3 plus 9. So 1/3 minus 28 divided by 3, or 1 minus 28 divided by 3 is equal to minus 27 divided by 3, which is minus 9. So these two terms will add up to minus 9. That minus 9 plus 9 is equal to 0. So t, when x is equal to minus 1, this equation is correct. So let's see what happens when x is equal to 2. So when x is equal to 2, 2 to the power x is equal, 2x is equal to 2 times 2, which is 4. That 4 plus this one is 5. So this will be 3 to the power 5. Minus 28 times 3. So x is equal to 2. So this will be 3 to the power 2. That will be 9. So here is 3 to the power 5. Here will be 28 times 9 plus 9. So 28 times 9, right? So 28 times 9 is equal to 280 and 252. So 3 to the power 5 is equal to what? So 3 to the power 5. Alright, so that will be 27 times 9. So 27 times 9 is equal to 243. So 243 plus 9 is equal to 252. So here will be minus 252. Again it is 0. Right? So both x equals minus 1 and x equals 2 are correct. So x equals minus 1 and x equals 2 are the solutions of this equation. So in this video I use this video to explain you what happens when you are given an equation of powers. So this is an equation of powers. How we can solve that is that you have to take some substitution here. So in order to do that substitution, you need to convert it into some format in which you get only one term, whether it's powers or whether there's a coefficient, it doesn't matter. You have to isolate one term here. So I isolated 3 to the power x here, 3 to the power x here, and I directly substituted, converted this into a quadratic equation, found the solutions, and then did the converse thing, right? Converse thing where I substituted here. I did the converse thing where I wrote t equals 3 to the power x here and found the values of x, and in order to confirm that whether the values are correct, what I did was that I substituted the values and wanted to know whether this left hand side is equal to the right hand side, which is 0. So we found the solutions to be correct. So that is the way, right? That is the way by which you can solve an equation of powers. So in the next video I'll be talking about another concept of indices, and see you then.